You've probably experienced it. The entire day is painfully hot. The sun feels like it's melting the ground, and the air is so still and heavy that even breathing seems like effort. And then, out of nowhere, the wind starts picking up. Dark clouds gather on the horizon, the sky darkens, and a thunderstorm erupts. Lightning, thunder, a sudden downpour, and just like that, everything changes. But is this just nature being dramatic? Or is there a scientific reason why hot days so often end in storms? The truth is, this sequence of events is anything but random. In fact, thunderstorms following heat waves are a direct result of basic atmospheric physics. When the sun heats the ground throughout the day, that heat doesn't just stay at the surface. It warms the layer of air just above it. And because warm air is less dense than cold air, it rises. As it rises, the air expands and cools, roughly by 1 degree Celsius for every 100 meters of altitude. If this rising air contains enough moisture, which is often the case on humid summer days, it will begin to condense as it cools. Water vapor turns into tiny droplets, forming clouds. When this vertical motion is strong enough, it doesn't stop with small clouds. Instead, it leads to the formation of towering cumulonimbus clouds, those classic thunderstorm clouds that can reach heights of 10 to 15 kilometers. But something even more powerful is happening during this process. When water vapor condenses into liquid, it releases what's known as latent heat, energy that was absorbed when the water originally evaporated. That heat gets dumped back into the surrounding air, making it rise even faster. This creates a powerful feedback loop, rising, cooling, condensing, releasing heat, rising even more. That's how a thunderstorm engine is built, right over your head. As this system strengthens, it produces strong updrafts and downdrafts, which mix different layers of air with different temperatures and charges. This mix leads to electrical imbalances and ultimately lightning. Thunderstorms are not chaos. They're the atmosphere's way of releasing built-up energy and restoring balance. Meteorologists measure this potential energy using something called CAPE, short for Convective Available Potential Energy. It's a number that tells us how unstable the atmosphere is and how much energy is available to drive upward motion. High CAPE values mean storms are not only likely, they're going to be intense. But not every hot day ends with a thunderstorm. It depends on multiple factors: moisture in the air, overall instability, and whether there's a trigger to get things moving, like a cold front or even a mountain range. However, when the air is hot, humid, and unstable, storms become very likely. The heat is essentially loading the atmosphere with energy, and that energy can't stay there forever. So the next time you're sweating through a summer afternoon and the sky feels too quiet, too heavy, remember, what you're feeling isn't just discomfort, it's potential energy. And once the atmosphere decides it's had enough, that energy will explode, not by accident, but by design. For more fascinating videos, don't forget to like and subscribe to Almost Fiction.